This video is going to cover 3.2. Some of the stuff we did in class and some of them is added to it. And then most of the examples are different from the ones in the notes, so you'll want to change as we go. So first of all, one of the things we didn't discuss at all was the maximum number of turning points. And you won't be tested on this, but this is going to show up on your web assign. So the max number of turning points is n minus 1, where n is, again, the degree. So this is the degree, which it means the highest exponent. So this is the amount of times your graph can turn directions. If the highest exponent was x to the third, that means it has 2, because that would be 3 minus 1, or 2 max turning points. Now there can be less than that, but there can't be more than that. So if you have a cube function and it's going to point up to the right and it's going to point down to the left, it can turn once and it can turn twice, but it can't turn more than that. Or a typical x to the third can just turn once, again, because that's a maximum number of turning points. We talked about the end behavior, or the leading coefficient test, which tells us the end behavior of a graph. If it is a positive coefficient with an x to the odd power, then it falls left and rises right. If it's a negative with an odd exponent, then it rises right and falls left. If it's positive with an even exponent, then they both point up. So both arrows point up, and negative with an even exponent, and they both point down. And then we talked about the roots and the multiplicity. So to find the roots, which end up being the real numbers of those, end up being the x-intercepts, you're going to set f of x equal to 0. And then the multiplicity is the number of times that answer occurs if it's more than 1. If it has a multiplicity that is even, then it bounces off the axis at that point and turn around. If it's odd, then it crosses through. And then, as usual, we will find the y-intercept by plugging 0 in for x. So we're going to put all that stuff together in the next bunch of examples. And some of these examples we got to in class, and some of them we did not. This first example is f of x equals x to the third minus 2x squared minus 5x plus 6. And I had you change this to a 3, so that should be a minus 3. And we're just making it so that it's factorable, which is what you'll be tested on. So the first thing I want to do is look to make sure it's in order of decreasing degree, and this one is. The highest exponent is 3, which is odd. The sign on that term is positive, which means my end behavior, it's going to fall left and rise right. The 3 being there also tells you max number of turning points is n minus 1 or 3 minus 1, which is 2. Then I want to find my roots or my zeros. So I'm going to set this equal to 0 and factor. This time there's 4 terms, so I'm going to factor by grouping. From the first set of terms, I can take out an x squared, and I get x minus 2. Second set of terms, I can take out a negative 3. X minus 2, and then the greatest common factor is the x minus 2, and x squared minus 3 goes together. If I could factor that x squared minus 3 further, I would, but it's not a perfect square, so I'm going to split and solve these. I get x equals 2, x squared equals 3, square root both sides, and x would equal plus and minus the square root of 3. So there are 3 roots, negative square root 3, positive square root 3, if I put them in order of least to greatest, and positive 2. Each of these only occurs once, so the multiplicity is just 1. It's going to cross through each of these points. I'm going to approximate root 3, so let's say it's like a 1.7, 1.8, so that I can graph it. I'm going to go to the graph. I'm going to find negative 1.7, positive 1.7, and positive 2. Because it falls left, my arrow is going to point down on the right. Down on the left, and rises right, it's going to point up on the right. And then I know it's going to go up, come back down, cross through, and come back up again. And the question is how far? And that's where a y-intercept can help us. So the y-intercept, I would plug zeros in for each of the x's, and I end up with a y-intercept of 0, 6. So that's my y-intercept. I know I'm going to go up at least that high, turn around, come back down. I'm going to go just dip slightly in between these two, because if it's a small gap like that, it doesn't go far. And then I know it crosses through, so I have to come back up. Now, this is not exact. If you graph it on a graphing utility, it might go up a little bit higher or a little bit lower, which is okay. This is just an approximation. And if I had multiple choice, so like the homework, you're going to see this on then multiple choice, you should be able to pick your graph from there. All right, 7. So we're going to skip a couple to 7. And this one is already factored. It's in factored form. It says f of x equals negative x minus 3 squared, x plus 1 squared. So to find the roots are going to be easier, and the multiplicity, what's a couple more steps this time is to find the highest exponent. We don't have to multiply this out fully, but if I had squared this, the highest exponent would be an x squared. This would still be an x, and this would be an x squared. So if I were to multiply those terms out, I would end up with an x to the 5th. The negative on the front means it would be a negative x to the 5th, which tells me it's negative and odd, so it's going to rise left, fall right, and the max number of turning points is n minus 1, which is going to be 4. Then I would set these equal to 0. So 0 equals negative x minus 3 squared, x plus 1, and x plus 1 squared. Split and solve. The 0 multiplied by that negative 1 is going to go away, and I'd end up with x minus 3 squared equals 0, x plus 1 equals 0, x plus 1 squared equals 0. Now, I don't have to expand and FOIL this. What this means is that there are 2 of these parentheses, which means there would be a 3, and it would occur twice. On the second one, it would be negative 1 one time, and on the last one, it would be negative 1 2 more times. So I have 3 occurring twice, and I have negative 1 occurring a total of 3 times, 1 from this and 2 from this. I'm going to plot those, negative 1 and 3. My arrow goes up on the left and down on the right. My y-intercept, I'd have to plug in 0. So y would equal negative 0 minus 3 squared times 0 plus 1 times 0 plus 1 squared. And I'd get negative 3 squared times 1 squared. Negative 9 times 1 is negative 9. So now I know it's going to come. It actually would go off the graph a little bit. And it's going to come all the way down. It has to turn around to come back up because it's going to have to bounce off this coordinate point because it's got a multiplicity of 2 and look something like that. Number 8 is similar. The negative's on the front again. This time it's in factored form. So this would be an x squared. This would be an x squared. And the negative on the front would make this a negative x to the 4th. So they are going to both point down. Max turning points would be 4 minus 3, which is, 4 minus 1, which is 3. 0 would equal negative x plus 2 squared and x minus 3 squared. Multiply by negative 1, and that 0 goes away. That negative goes away. And I'd get 2 negative 2's and 2 positive 3's. So negative 2, positive 3, both point down. It has to bounce off this 2, however, so it's going to change direction and go down. And it has to bounce off the 3, which means it's going to point back down. My y-intercept is 0 equals, no, sorry, not 0. Y equals negative 0 plus 2 squared, 0 minus 3 squared, negative 2 squared, negative 3 squared, negative 4 times 9, which is negative 36. So this goes way down below my graph. I could just plot that point and label it. It's going to bounce, come down, come back up, and bounce again And there's the best approximation of the graph. All right, these I changed. So because what was left was not factorable, and what you'll be tested on is factorable. So these I changed. So this one says f of x equals x to the third plus 2x squared. My highest exponent is 3. So that tells me it's odd and it's positive. This is going to fall left, rise right. Max turning points would be 2 because it's 3 minus 1. 0 equals x to the third plus 2x squared, and I'd factor it. Take out the x squared, and I get x plus 2. Split and solve, and I get x squared equals 0, which means x would equal plus and minus 0. While that doesn't give me two different answers, it gives me 0, but it gives me 0 twice. And that's important now because it affects the multiplicity. And then here, x equals -2. So -2 and 0 are my answers. 0 has a multiplicity of 2. -2, 0, falls left, rises right. Now this time my x-intercept is also my y-intercept. So I don't know how high to make it in between here. And I'm going to plug in another point. The only point in between these two is -1. So I'm going to plug in -1. If there was more than one, I would just pick a point. So -1 to the third plus 2 times -1 squared. And I get -1 plus 2, which is 1. So now I know I go to 1. So it's going to cross through -2 because it's got an odd multiplicity, turn back around, and bounce off of 0 because it has an even multiplicity. Let's try another one. Again, I changed this one. So you want to do f of x equals x to the third minus 6x squared plus 9x. Highest exponent is 3 again, so this falls left, and it's positive. Rises right. Max turning points is 2 again. So 0 equals x to the third minus 6x squared plus 9x. I'm going to take out the x. Factor it. Factors the positive 9. That sum to -6 would be -3 and -3. Split and solve. And I get 1, 0, a 3, and another 3. Which means 0 and 3 with a multiplicity of 2 on that 3. 0, 3. Arrows point down on the left, rise on the right. It's going to cross through 0, but bounce off of 2. So it's going to come up, come back down, and bounce. To figure out how high it is, the y-intercept's not helping because we already use it as the x-intercept. So I can plug in a 1 or a 2. I'm going to make my life easier by plugging in the 1, and it doesn't matter. So 1 to the third minus 6 times 1 squared plus 9 times 1. 1 minus 6 plus 9. And I get positive 4. So it's going to go up to 4. It's going to turn back around and bounce off of 3. And again, it might go higher than that 4. Like if I plug in 2, it's going to be a bigger number. It's going to go higher than that. And that's okay. This is just approximation from multiple choice, and that enough information should be provided for you to make that pick. All right, this one, now I've got an x to the fourth. So my fourth tells me it's even and it's positive, so they both point up. Max turning points would be 3. 0 equals x to the fourth minus 5x squared plus 4. When I factor this, the first term would be x squared. And then I'm looking for the factors of positive 4 that sum to -5. So -4 and -1. And those are both the difference of two squares, so I can factor further. Split and solve, and I get -2, +2, -1, and 1. So 4 different answers. Multiplicity of each is 1. Both point up. This time, the y-intercept can help me figure out how far to go down in the middle. So if I plugged in 0, I'd get 4. That tells me 0, 4 would be my y-intercept. Now it's going to cross through, come back up, cross through, come back down, cross through, and come back up. And I just approximated how low to go in between that -2 and 1. If you needed a more precise point, you'd have to plug in, and it would have to be a fraction this time. So like a -3/2 or a +3/2. A graph like this has symmetry, so whatever happens on the left is happening on the right, and that could help you save at least 1 point. But there should be enough information based on this to then select your graph. All right, so that wraps it up. I know this was a very modified 3.2, but now you should be able to do that 3.2 assignment on WebAssign.